This is a typical Jamb question, right? Now, I'm going to solve this question, explain the principle behind it, so that when you see any question related to half-life, you should be able to solve the question. So what I'm going to do is that I will solve this question, then give you related question. My expectation is that you would use the principle in this question to answer the next question. So pay attention, watch it over and over so that the principle will remain in your brain. That is the idea of studying for an external exam using past question. As you use past question, it is the principle that you learn. Don't expect this same question to come out from your next exam. Is that clear? So let's proceed. A piece of radioactive material contains 1000 atoms. If its half-life is 20 seconds, the time taken for 125 atoms to remain is, what is going to be the time taken for 125 atoms to remain? Now, what is the idea of half-life? Do you still remember half-life? Right? Now, half-life is the time taken for half of an atom initially present to remain. That is the half-life of that atom, right? So let's solve this. Solution. Good. Now my half-life is what? The half-life is 20 seconds, right? My half-life is 20 seconds, right? The number of atoms n, number of atoms present are what? 1000 atoms, right? These 1000 atoms. Good. So the first half-life, let's do the first half-life, that is the first half-life, which is 20 seconds. After 20 seconds, what is going to happen to the atom? After 20 seconds, I'm going to have 1000 divided by 2, because after 20 seconds, it is half of the atoms that is going to remain, right? So after 20 seconds, I'm going to have, from here, I have 500 atoms is going to remain. All right, before we proceed to the final answer, don't forget to subscribe if you have not. Don't forget to follow if you have not, right? Stay back for the final answer. Thank you. This after 20 seconds. Now the next half-life is going to be another 20 seconds, which will give us how many seconds? 40 seconds, right? So the second half-life now, the second half-life is going to be what? 40 seconds. The second half-life is going to be 40 seconds, right? So after 40 seconds, the number of atoms is going to be what? 500 divided by 2. Are we all together? So what I'm going to have here is 250 atoms, right? The next half-life is addition of another 20. After how many seconds now? After 60 seconds. So the third half-life now, that is after 60 seconds. What is going to be the number of atoms remain is going to be 250 divided by 2, and this will give me 125, right? Good. Now go back to the question. They said if its half-life is 20 seconds, the time taken for 125 atoms to remain is, now you see that is what? 20 seconds. So it takes what? 20 seconds for 60 seconds for 125 atoms to remain. So you see, our option is what? Is C. So C is the correct answer. The principle here is that when my time is increasing, The number of atom is that I'll be dividing the number of atom by 2, that is the half of it, half of it. That is the principle. I have the first one, 20 seconds. When I add 20 to 20, what I'm going to have? 40. The next one, if I add 20, that's after another half-life, after 20 seconds, I'll add 20 to it, will give me 60. What is happening to the number of atoms? Keep dividing by 2. So that's the idea of what? Idea of half-life. Is that clear? Good. If you don't understand, please ask question, use the comment section, right? And solve these questions for me related to this half-life. Similar question, apply this principle and solve this question for me. Let me see. Okay, you see these activities I would like you to do for me. These activities, I will just explain them briefly just to give you an idea, right? It's the same principle here that you are going to apply here. Good. Just that you need to think and add one or two things, right? Okay. Now this is a question that says a radioactive element has a half-life of 4 days. The fraction that has decay in 16 days is, what is the fraction that we are going to have after 16 days, right? That is, what is going to be the atoms that will remain after 16 days. Now, in this question, we follow the same principle, that is, the days that I have, 4 days, right? After 4 days, half of the atom will remain. The next one is what? Add 4 to it again. After 8 days, half will remain. After another 4, add to it, right? Making what? 12. Add to it, making what? Continuously like that, right? Then what about the number of the atoms? Thing is that we don't know the number of the atom, n, right? So after 4 days, I have n over 2, right? After another 4 days, which is what? 8 now. So I'm going to have what? N over 2, right? Times 1 over 2. That means I'm going to have n over 4, right? That's after 8. If you add another one, right? After 12 now, what is going to be this? You divide this by 2. You perform the mathematic fraction, right? We have 12. Then you add another 4 to it, that is 16 now. You divide this one now by 2 again. You do the mathematics. When you do that correctly, you will have your answer here among these options, right? Good. Do it. If you're still confused, you can ask the question. Now, this one, the time it will take a certain radioactive material with a half-life of 50 days to reduce to this fraction to 1 over 32 of its original number is the time now. So for this one, you keep going until you have a fraction with a denominator of 32. Then you notice that the time is going to be in the option here. Very simple, right? So check it out. In case if you're confused along the way, just go ahead and ask your question, right? Thank you.